Okay, so here we consider the following integral. It's integral of x minus 1 over x squared plus 2x plus 2. Notice that the degree of the top is 1, the degree in the bottom is 2. So we may think of using the partial fraction decomposition. But the problem that we have is that the denominator here cannot be factored. So x squared plus 2x plus 2, if you try to factor it, this doesn't work. You can't find two numbers, their product is 2 and their sum is 2 at the same time. And also if, we don't have rational numbers satisfying this. And if you try to use the quadratic formula, that's not going to work since you're going to have complex roots. So this is not factorable, okay? This is prime, we call it prime. This cannot be factored. Okay, so what do we do in this case? Well, we do have an option, and this option is completing the square. So we will try to complete the square of the denominator. And the reason we think of completing the square is because of the following. Recall that we know how to integrate a linear function, let's say ax plus b, over x squared plus 1 or x squared plus any number. Let's say x squared plus 1 because we did this before. Okay. You split this into two fractions. One of them will be arctangent and the other one can be done by substitution. Okay. So our goal is to complete the square so I can have something raised to the power 2 plus some constant. So let's recall the completing square formula. Given any quadratic factor of this form, this can be written in this form. By completing the square, you factor out a, you get inside x plus b over 2a squared minus b over 2a squared plus c. Then, if I want to apply this in here, I have x squared plus 2x plus 2 equal, now a is 1, so this becomes 1 times x plus 1 square minus 1 square plus 2, which is x plus 1 to the power 2 plus 1. So that means that my integral can be written in this form, integral of x minus 1 over x squared plus 2x plus 2 dx. This is equal to the integral of x minus 1 over x plus 1 squared plus 1 dx. Now remember that I still didn't have the integral that I want, okay? Because the form that I want is the one in black here, which is ax plus b over something to the power 2 plus 1, some variable to the power 2 plus 1. I do have x plus 1 squared, so for this reason, it will make sense now to let this be u. So we let u equal x plus 1, which means du is just dx. Therefore, this integral, x minus 1, the original one, x squared plus 2x plus 2 dx, can be written as the denominator is u squared plus 1, dx is just du. Now, I have x minus 1 and I should write my integral in terms of u. The integrand must be in terms of u. From this equation, I can conclude that x is equal to u minus 1. That means the numerator, x minus 1, is just u minus 2. Well, this looks exactly like the one I wanted, like the one in black on the top here. So to finish this integral, I can split this into two integrals, u over u squared plus 1 du minus 2 times integral of 1 over u squared plus 1 du. Now for the first integral, we will use substitution. And we can see why, because look, the derivative in the bottom is 2u, and I have u in the top here. So this integral, I'll just do it by itself, u over u squared plus 1 du. We're gonna let t be u squared plus 1. So that means that dt is 2u du. So du is dt divided by 2u. So this becomes integral of u over t times dt over 2u. Cancel by u and u. You get 1/2 integral of dt over t, which is 1/2 ln absolute value of t. We'll add the constant at the end of our result. So back to u, that's 1/2 ln absolute value of u squared plus 1, which I can write actually without the absolute value, since this u squared plus 1 is always positive. Okay. So this is the antiderivative of u over u squared plus 1. Now regarding the other integral, 1 over du, 1 over u squared plus 1 du, this is just tangent inverse of u. So as a result now, the integral we have, so therefore, our integral x minus 1 over x squared plus 2x plus 2 dx, this is equal to, the first one we said it's half ln of u squared plus 1 minus 2. The second one is tan inverse of u, and just add the constant here. We still need to go back to x. Okay, remember that our choice of u was x plus 1. So instead of each u, we're gonna write x plus 1. So that's 1/2 ln of x plus 1 squared plus 1 minus 2 times tangent inverse of x plus 1 plus constant. We can expand the inside here if you want. So that's 1/2 ln x squared plus 2x plus 1 plus another 1 plus 2 minus 2 tangent inverse of x plus 1 plus constant. So this is the result of the integral. This is the case when you end up with an integral with a quadratic factor in the denominator that's not of the form x squared plus some constant and that cannot be factored. So in this case, you must be using the completing the square.